Hey guys, our last target, 1D, has to do with surface area and volume. So we are going to look at our area formulas first, right? Area is really just the two-dimensional space a figure occupies. This is a two-dimensional object, right? So flat. The area of a triangle, right? Area equals 1/2 base times height. You should have seen this before. Area of a circle, right? Area equals 1/2 pi r squared. Right? The one thing I didn't put on here, maybe I should have, is the area of like a rectangle. But I feel like that's the one people remember the best. Right? And the area of a rectangle is simply length times width. Okay? So those are our area formulas. Then we want to use those to find our volume. So now volume is the three-dimensional space a figure occupies. So now, how I think about area is you take just whatever the base, or sorry, what I think about volume is you take whatever that base is and you just stack it up on top of each other a lot, right? So for prisms and cylinders, right, I have like that triangle, if I look at the triangular prism, and I'm just stacking it up on top of each other. So all I have to do is find the area of that triangle and then multiply it by the height. Oops, sorry. Same thing for a cylinder, right? That's the area of a circle, and I'm stacking it up on top of each other. So it's just the area of the base, right? So for here, that's my base. Here's my base. And same thing for this rectangle, my base, right? And I stack them all on top of each other. So I just multiply that by whatever that height is for all of those. Okay. For pyramids and cones, it's a little bit different, but not too bad. Pyramids and cones, I still start with whatever that base is. So if I have a triangle pyramid or a rectangular pyramid, I have to find that base, or a cone, that base is a circle, right? I'm kind of stacking them all up on each other, so I still am going to have a height for all of those. However, it's slanted in, so it's actually a third of it, right? If I filled this out and made it a cylinder, it'd be 3 times as big as that cone. So the ones that slant in are just a third of what they usually are. And then finally we have spheres, which are completely different, and it's 4/3 times pi times radius cubed. So whatever my radius is, times pi times 4/3. My radius would give me from the center out, and I just multiply it by those. I don't think we're going to look at spheres that much. We might have to look at a little bit, but this formula will probably be given to you. Then the last thing we want to look at is Cavalari's principle. There's that. Which is just if an image is slanted. If we look here, I have 3 different figures. So if I have 2 or more figures that have the same height and the same cross-sectional area at every level, they have the same volume. So if you look, this is just a square here. This is called a cross-section. I'm just looking at one little paper-thin slice of this shape, right? All those have that same cross-section, and I can make that cross-section anywhere. I could look at it down here, right, and over here, and on this one. They all have the same square cross-section at every level. Right? Think of it as a building. So that means they have the same volume. It doesn't matter that they're all squiggly like that. Okay? And that's all our vocab for this target. So see you guys later.